Can anyone describe to me what density means? Yeah, that's pretty good. How close the atoms are together, kind of. How dense something is, right? You can't really use its term in its definition. But how close together, how tightly packed atoms are. Okay? Density is an intensive property of matter, which means intensive property of matter. Yes, Patrick?
It won't change if you add more substance.
Perfect. Good description. It will not change if we add more of the substance. For instance, the density of water is 1 gram per milliliter. What that means is that 1 milliliter of water, when I measure out 1 milliliter of pure exact water, it would weigh exactly 1 gram. That's what density is. And so if I add 100 milliliters of water, what would it weigh? 100 grams, right? The property of density does not change based on the amount of substance I have. Very good. Okay. Whoa. The equation for density is D equals M over V. Really important. Write that down. Star it, highlight it, do whatever you need to keep track of that equation in your notes. Okay? Density is equal to mass over volume. Okay? It shows how compact or how tightly attached our atoms are. Okay, so if we know that the density of water is 1, if I have something with the density of 0.8, what will it do when I put it in water? If I have a density of if something has a density of 0.8, what would happen when I put it in water? Would it float or would it sink? It will float, right? It is less dense than water. Okay, if I have something of a density of 5, what would happen when I put it in water? It would sink, right? Most metals have densities higher than 1, so they'll sink in water. Density is usually measured in this unit. Mass is measured in grams. Volume is measured in milliliters. So the units for densities are grams per milliliter. Or sometimes you'll see it as grams per centimeters cubed. Because last time I told you that a cubic centimeter is the same as a milliliter. A cubic centimeter holds the same amount of volume as a milliliter.
The D equals M over V is
That's the equation. That's how you solve it. This is the units. That's what you'd label it with. Grams per milliliter. Okay? You can label it with different things, but it is dependent upon what your mass is measured in and what your volume is measured in. Okay? If I have kilograms over liters, that's how I would measure my density, kilograms per liter. Okay? So it just depends on the units you're given for your mass and your volume. Okay? All right, we already talked about that. We don't need to go into that a whole lot. All right, determine the density of an object that weighs 16 grams and has a volume of 0.35 cubic centimeters. So here's my equation. Density equals mass divided by volume. This value right here, 16 grams, what variable is that for me? Is it my density, my mass, or my volume? It's mass. So M equals 16 grams. Volume equals what? 0.35 centimeters cubed. That is my volume. Does the cubed on that have anything to do with the number? No, the cubed has nothing to do with the number. It is a cubed unit. So it has nothing to do with the number. You do not cube that. All right, so if I wanted to find density, I would take 16 divided by 0.35, and I would say that I have a density of what? 45 point what? 7? That's fine. And my units would be grams per centimeters cubed. Okay? What did we talk about with units last time? Should we include them on every number or not?
Yes.
Yes, we should include them on every answer. Okay, we need to have units there. Yes, Lucas. I don't care where you round. I don't care where you round. Okay, for most things, I like 2 decimal places. We're going to learn within the next week in this unit about how many we should round to, but for right now, I don't care. Okay. Next one. A certain compound has a density of 3.21 grams per milliliter. If I have 28 grams of my substance, what's the volume? So here I'm solving for a different part of my equation. Did we all see where those variables came from? And we agree with how they're labeled? This is my density. If you can't tell based on context clues, look at the units, right? Grams per milliliter is my unit for density. Here's my mass. It's measured in grams. Volume, I don't know what it is. Okay, so now I plug it into my equation. And I would say 3.21 equals mass, which is 24.8, divided by volume. Right? And I need to solve for V. How can I solve for V? Do I just multiply these two together? No. Okay, so I'm going to walk through the algebra to get there. Okay? And then I'll show you a little shortcut. But I want you to understand the algebra first. If I have V that I need to solve for in the denominator, what's the first thing I need to do? Multiply both sides by V. Right? So now I'm left with V times 3.21 equals 24.8. Agree? We don't subtract because these are multiplied together. So now I divide by 3.21, divide by 3.21. And that leaves me with V equals 24.8 over 3.21. Okay, does that make sense algebraically how I got to that? The shortcut with that is that if I have my variable on the bottom of this triangle type equation, I just switch these two places. Okay, let me show you that again. See this triangle type equation that I have? You're going to see a couple of these in chemistry. When my variable is on the bottom, I switch these two places. And I end up with V equals 24.8 divided by 3.1. Okay, solve that out and tell me what my volume should actually be. 8 something? 7s?
7, 2,
Okay.
6.
My volume should be measured in milliliters. And how did I know it was milliliters and not liters or centiliters or something else? Right, my density was measured in grams per milliliter, which means my mass had to be grams and my volume needed to be milliliters. Okay, questions with density?
Do you not want to go around that much?
I don't care. No, don't care. Yes, Patrick?
But the units can be different. Like they can be.
They could be different as long as they are consistent. So if my density was measured in kilograms per liters, my mass would have to be kilograms, my volume would have to be liters. So they could be different, but they have to be consistent. Does that make sense? Okay. Here we go. I have 0.32 liters of a substance with a density of 2.19 grams per milliliter. What's the mass of my substance? Let's try this one on your own. Try this one on your own. Make sure you read it very carefully. Are not taking the time to write out your list, and you need to make time for that. Volume equals this, density equals this, and mass equals my question mark. Okay, you need to make time to write out that list so you know what variables you have. The red flag here should have come when we saw we had liters and milliliters. Okay, and the easy fix for me is to convert liters to milliliters with my volume, right? That should have been your first step, and I didn't see many of you make that as your first step automatically, right? I put this problem out there on purpose so that you check your units, okay? So if I want to go 0.32 liters to milliliters, I would say 1 liter is 1,000 milliliters, which means I'm at 320 milliliters. Okay? So my volume now is 320. When I set up my density problem, I would say 2.19 equals mass over 320. And to get m by itself, all I need to do is multiply by 320 on both sides. Okay? That way it's canceled. You have to do less math here because my variable is already in the numerator. Okay? Yes.
But when it's asking for the answer, it's asking what the mass would be if you had. Oh wait, never mind. I guess it would be the same, but like when they're saying if we had 0.32 liters of the
Right.
substance.
Right. Since
When
we
we're
know
working
what...
with liters, should we always work with?
You just need to make sure that these are consistent.
Yeah.
Right. I would have converted first. The way you did it, I think, is still right. Because I think the answer we should get is how many grams? 700? 0.8 grams. So you still got the same thing. You just went a little bit roundabout, which is okay. Okay, but for consistency's sake, that's how I would do it.
Wait, why are you at kilograms?
I didn't know why I put kilograms. It's grams. So sorry. Just grams. 700.8 grams. How many of you had that? Okay. Only a few. How many of you were 3 orders of magnitude off because you forgot to convert liters to milliliters? Okay. All right. All right. We're going to stop right there with notes for